This is the second video for your Unit 2 Pre-Cal test review. We're picking up with question 15. We did 6 through 14 in the first video. The first 5 questions were just definitions and formulas. So we started with question 6 on the review. So 6 through 14 in the last one, picking up here with problem 15. Draw a 30, 60, 90 triangle. Label the lengths of the sides. Using these sides, give sine 30, cosine 60, secant 30, cotangent 60. Alright, so let's draw this triangle here. 30, 60, 90 triangle. So 90 here, 30 is here, 60 is here. So the shortest side, the 30-degree angle points at, this medium side, the 60-degree angle points at, the hypotenuse, the 90-degree angle points at. That's the way any triangle is, and that's basic, but it's important to understand that. So the lengths of the sides, we have the hypotenuse is 2, the 30-degree side is 1, and the 60-degree side is square root of 3. So 2 is bigger than square root of 3. Square root of 3 is bigger than 1, so it all makes sense there. And we have already established that in previous lessons, so I'm not going to go through where that comes from. Those are just the ratios of any 30, 60, 90 triangle. Now let's apply it. So if we're using the sine of 30, so sine of 30 is equal to, sine is, let's write this up here. So cotoa, so sine is opposite over hypotenuse. So from the 30-degree angle, let's use another color here, this is the opposite side, 1, over the hypotenuse, 2. And next we need cosine 60. Cosine of 60 degrees is equal to adjacent over hypotenuse. That's this. Cosine is adjacent over hypotenuse. That's where that saying comes from. So from the 60-degree angle, the adjacent side is 1, and the hypotenuse is always the hypotenuse. That never changes. The adjacent and opposite sides will change depending on if you're talking about this angle or this angle, but the hypotenuse is always the hypotenuse. So adjacent 1, hypotenuse 2, 1/2. Cosine 60 is 1/2. Next, secant of 30 degrees. So secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. It's just the reciprocal of this right here, so hypotenuse over adjacent. So from the 30-degree angle, hypotenuse is always the hypotenuse, and then the adjacent side would be the square root of 3. We want to rationalize that denominator, so we get 2 square root of 3 over 3. So secant 30 is 2 square root of 3 all over 3. Next, cotangent of 60 degrees is the reciprocal of tangent, so it's adjacent over opposite for cotangent. So adjacent over opposite. And from the 60-degree angle, the adjacent side is 1, the opposite side is root 3, so 1 over square root of 3, rationalize it, so square root of 3 over 3. And that's it for problem 15. Let's go to 16. 16 says, given point 5, -7 on the terminal side of an angle theta in standard position, determine the cotangent and cosecant of theta. So we'll start with a sketch. It's always a good idea to sketch these. Helps you visualize what's happening. So x is 5, y is -7, so that tells us we're in quadrant 4 down here. So our y value here is -7, our x value here is 5, so x is 5, y is -7. To use to establish our trig functions with the x, y, and r definitions, we need x, y, and r. So we're given x and y, so we can find the missing piece r by using our Pythagorean theorem. So we'll rearrange that just a bit, and we get this. So we just fill in the values. R is equal to, this would be plus or minus square root, but r is always positive, so we're only taking the positive square root of 5 squared plus -7 all squared. And we'll bring up our calculator, and that would be square root of 5 squared plus parentheses -7 squared, and that is 8.6. Because that's a decimal and we need to establish trig functions, we're going to leave it in terms of a square root. So 5 squared plus negative 7 squared. We're just going to take the square root part off from our calculator, so equals the square root of 74 there. 8.6023 is square root of 74. So we're going to use square root of 74 because we're using the trig functions and we don't want to put 8.6023 in the numerator or denominator every time. So square root of 74 is appropriate here. Determine the cotangent and cosecant. So cotangent theta is the reciprocal of tangent. So tangent is x over y, y over x, so this would be x over y. And then cosecant theta, CSC theta, is the reciprocal of sine. Sine is y over r, so this would be r over y. So we just fill that out. So that would be 5 over negative 7. And cosecant theta, r is equal to the square root of 74, y is negative 7. So there's our two answers, negative 5/7 and negative square root of 74 all over 7. So that's it for 16. 17, similar to 16, as far as the type of problem, given this point, terminal side, determine sine and cosine. So we make our sketch. Negative 3, 8 would be in the second quadrant, negative 3, 8 about right here. Use another color there. So this point is negative 3, 8. And that tells us x is negative 3, y is positive 8. R is going to be the square root of negative 3 squared plus 8 squared. So r is equal to the square root of 9 plus 64. So r is equal to the square root of 73. We're just going to leave it that way because we're finding trig functions here. We don't want the decimal equivalent of this. So sine of theta is equal to y over r. So in our case, that would be 8 over square root of 73. We need to rationalize that denominator, so 8 square root of 73 over 73. Cosine of theta is x over r. So in this case, that would be negative 3 over square root of 73. Rationalize, negative 3 square root of 73 all over 73. So our two answers are 8 square root of 73 over 73 and negative 3 square root of 73 all over 73. So that answers the question. We could label our picture a little better technically. There's theta. So our two answers are down here. So let's go to 18. All right, problem 18. Determine the sine and cosine of 11 pi over 6 radians. So this is just a problem where they're asking you in a different way to apply your special right triangles and reference angles. So those two concepts. At this point in your trigonometry career, you're not as familiar with radians, so it's always okay at this point to convert them into degrees, the radian measure into degrees, and then work with it from there. So let's do that. 11 pi over 6 times 180 over pi. So the pi's cancel. That's what we want when we go to degrees. And we get 11 times 180 all divided by 6. So we'll do that here. 11 times 180. And then divide that by 6. And we get 330 degrees. Okay, so now we can sketch a picture. Always sketch these pictures. 330 degrees would be almost all the way around to about right there. So there is 330 degrees right there. And that means that we have a reference angle. The reference angle is defined as from your terminal side to the closest part of the x-axis, and it always needs to be an acute angle, so less than 90 there, and that would be 30 degrees. So we have a special right triangle here. So this would be the hypotenuse, this would be the 60-degree angle. So from there we can get all of our sides. The 30-degree side is 1, the 90-degree side, the hypotenuse is 2, and this is the 60-degree side, so root 3. And this one needs to be negative. Okay, so here's what we have. If you wanted, you don't even have to worry about, you could use SOHCAHTOA here, sine, cosine. Our sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, or you can use x, y, and r. We've done the SOHCAHTOA before in this video earlier on in a problem, so this time we're going to use x, y, and r. So x is square root of 3, y is negative 1, and r is 2 in this problem. There's x, there's y, there's r. So we want to find these two, no problem. So sine of 11 pi over 6 radians is equal to y over r, so that would be negative 1/2. Cosine of 11 pi over 6 radians is equal to x over r, so that would be square root of 3 over 2. And that answers our question. You just need to realize 11 pi over 6, same thing as 330 degrees. So here are our two values, negative 1/2, square root of 3 over 2. Those are our answers right here. This is what you're looking for, this and this. Okay, I'm going a little faster through these problems. Obviously, this is a review, so if you have trouble with any of this, applying the reference angle, applying the 30, 60, 90 triangles, then you need to go back through the lessons where I discuss that in more detail. And all of those are available in the Unit 2 playlist as well. All right, so that's it for this video. We'll pick up problem 19 in the third video.